2. We're going to take a look at a few things, about half of this. I think we'll go to about page 47 by the time we're done. A couple things. We have cases and variables, which we've talked about in chapter 1. But then there's this topic of quantitative and categorical data. And you will see throughout this section that there are different ways or different types of graphs that you would use for each of these. You can see in the first paragraph here, I want to switch over to highlighter a second. Oh, I think it's this one, and we'll go yellow. Okay. 3 kinds of plots for quantitative variables, and those are dot plots, histogram, stem plots, and then 1 plot for categorical, and that is the bar chart. Now I want to take a look at the next page here. Okay, we have this nice list of mammals, and you can see across the top we have different variables. So the mammals, each mammal would be a case. So a baboon is a case, a grizzly bear is a case, etc. And then across the top we have the different variables: gestation period, average longevity, maximum length, speed, wild, and predator. Notice how the first 4 categories, first 4 variables are numbers. The values actually have numbers. Now you might look at the last 2 and say, well, they're numbers too, it's 1s and 0s. But look what the 1s and 0s are standing for. 1 is a yes, 0 is a no. So you could replace each of those 1s and 0s with yeses and nos. And what it is that wild and predator, those 2 variables, are examples of categorical data. Okay? And so if you have, or categorical variable. So if you have a variable that is categorical and you want to make a graph or a plot of it, just like the previous page, you would definitely need to be using a bar chart. You would not want to do a dot plot or a stem and leaf plot, etc. for those categorical variables. Okay. I don't know if we're going to get it to work today. Hey, there we go. So you got the definitions here: quantitative variable or numerical variable, a variable that takes on numerical values, versus categorical. Here it says a variable that can be grouped into 2 categories, such as yes or no. Notice it can also be ordered such as small, medium, and large. It doesn't have to just be 2 categories. It could be 3 or 4. It doesn't really matter. But it's non-numerical in nature. Okay. Now you can see we got just going to go through a series of different plots here before we call it good for today. Here we are at the top of page 44, more on dot plots. I would say the main thing that I want you to pull out of these, you're going to work with these types of plots quite frequently, but on the margins to the left, there's a lot of useful information throughout the book that they actually put these little tidbits of info in the margins. Okay, and so when are the dot plots most useful? Well, I have highlighted in my book, and I'm just going to do it here, and it makes it sometimes, it's kind of fun if I keep doing it over and over and over and over and over. See ya? I'll get rid of that. So, the 4 bullet points here, if you have a relatively small number of values, because remember, if you have a ton, you have to put a dot for every single data value. You want to see individual values. That is one characteristic that is very nice about a dot plot. You can look at each individual dot, and you know, for instance, up here, there was one at, I'm going to say it was about right at 70. You know there was one occurrence, all right, at 70. It's very clear from that. You can also see the shape of the distribution. We've seen that a little bit with some of the activities we've done in class, where we can start to see the mounding shape occur. And then the last one, you have one group of small number of groups you want to compare. Okay? So just some of these things you would want to be, if you get a question of, on the test, when are dot plots most useful, you want to be able to remember some of these. Okay, kind of the same thing with histograms. Okay, talks about dot plots show individual cases. All right, to make a histogram, you would divide the number line in intervals or bins. All right, and over each bin, you would construct a bar that is a height equal to the number of cases in that bin. Okay, so you're showing groups of cases where the individual dots are each individual number that occurs. Let me go on to the next page here a minute. Talk about this one here. We got the speed. All right, so we're broken into chunks of 5 here. If you look in right through here, so there'd be a bar, no bar here, no bar here, and so this one starts at 10 basically and goes to 15. So we do not know what exact speed is in there, but we can see from the 2, there were 2 mammals that have a speed between 10 and 15. Go to the other extreme, we have this bar up here, and it goes from 70 to 75, and the height of the bar only goes to 1, so we know there was 1 mammal that had a speed between 70 and 75. So unlike the dot plot, we do not know the exact number, we just know it's somewhere within that range. Okay? Over here you can see in the side margin, borderline values go to the bar to the right. So that would be the one above it, slightly higher. Okay. Talking about the width of the bars, you can see here they changed the width of the bars to be every 10 miles per hour instead of every 5. We're going to discuss tomorrow in class some pros and cons, or advantages and disadvantages to making the bars really narrow, which means the range of numbers very small, and advantages and disadvantages to making them wider, or the range of numbers larger. Okay, so just realize that that range can be set, and you could reconstruct it. All right, and it would look different, and that's one of the things we want to talk about when we might want to do either one. Okay, go to the next page here. Tomorrow in class, we will spend some time looking at calculator note 2C. So if you can make sure you bring your calculator notes with you. We are going to take a look at these data sets here, or we will take a look at some data sets so that we can hopefully, I don't know why it's not writing here, I apologize. There we go. And we're going to want to construct that in class so we can see. Notice they've changed the width of the bars there as well. Okay. Here again, when are histograms useful? The bullet points to go with that. You have a large number of values, which is just opposite of that of the dot plot. You don't need to see individual ones, so again, just opposite of dot plot. You want to see the general shape of the distribution, so that they have in common. Dot plot and a histogram both will allow you to see the shape. You only have one distribution or a small number of distributions. That's the same as a dot plot. You can use a calculator or computer to make the plots for you. All right. Now you've seen in class that my software that we use in class, Fathom, that will make dot plots, but that is an exception to the rule. Your calculator will only do the histograms, not the dot plot. So the fact that you can get it to be done electronically, that is nice. All right. One of the last things we need to talk about here today, before we call it quits, is the relative frequency histogram. Okay? It says a histogram shows frequencies on the vertical axis. We saw that with the speeds. You know, one mammal or two mammals had speeds that range from something to something else. Okay? It says to change a histogram into a relative frequency histogram, divide the frequency for each bar by the total number of values in the data set and show those relative frequencies on the vertical axis. Now, we're going to take a look at this example of converting the frequencies to relative frequencies, and I'm going to want to jump back and forth here just a second because the graph is actually on the next page, which obviously if you have your book open you can take a look at it. The math here, it says 4 of the 18 mammals had speeds. Here's the range, 30 to 35. Convert the frequency 4 to a relative frequency. So because there were 18 total, you're simply going to divide 18 by 4 divided by 18, and so you get the 0.22. Okay? Now, this is where I want to be able to look at the graph. Here we go. Notice the vertical axis, the y-axis. It is now labeled relative frequency, not frequency, because if it was just plain old frequency, it would be back to that 1, 2, 3, 4, etc. Okay? Now we are going to be limited to basically 0 to 1. Think of it in terms of percents, okay, or the decimal version of the percent. And the last one was 0.22, and that was, I believe, 30. Oh, no. I'm blanking. Let me look back in my book here a second. Yeah, the speeds were ranging from 30 to 35. All right. And so, I'm sorry. I did that example, but this histogram is for the next one after that. So I will either edit this part out, or you'll just have fun laughing at me. Either one, I can live with. All right, the next example, the life expectancies, is what the next one is for. Okay. So let me read this example here. So we got display 2.28 shows relative frequency distributions of life expectancies for 203 countries around the world. How many countries have a life expectancy of at least 70 but less than 75? What proportion of the countries have a life expectancy of 70 years or more? So we've got a couple questions going on here. Now I will go back here. So life expectancy from the first one, at least 70 but less than 75. So that. So at least 70, but no more than 75. So we're looking at this bar right here. So I'm thinking it's going to go over to the, pretty much right to the 0.3. Okay? And so what we would say is 30% of the countries here have a life expectancy between 70 and 75. Now, the question didn't say what percentage or what proportion, okay? They want to know how many countries for this first question that is. Well, it told us that there were 203 countries. I want to be able to write here a second, so let me switch this back. So we're going to take 30% of the 203 countries. The math they have right here, okay, the 0.3 times 203, and that equals about 61. So this is 61 countries are the answer to that first question. Now, there were a couple. The next one says, what proportion of countries have a life expectancy of 70 years or more? So now, here's the 70 years. Now they want everything to the right. All right? So we have the first bar, which we already said was 30%. Then the second bar here, we have to include that. That looks like 20% to me. And then this last bar, because this is, remember, it's 70 or more. I'm going to guesstimate, let's go 0.7, so, or 0.07, excuse me, so 7%. And it looks like they chose down here 30%, 19%, and 7%. So a grand total of 56% in their case, or 57% in mine. So we need to make sure we are paying attention to whether or not they're asking us for the actual number or the percent/proportion. Okay. that's where I'm going to call it today. We will have some discussion questions in class. Tomorrow's video, we will finish up lesson 2.2 on stem plots and bar charts. Okay? So I will catch you guys later.